What makes a good goal? That's the question that we're going to discuss in this segment. And as we talked about in the introductory video, we know that goals are first of all to clearly identify the learning outcomes of our lesson. They're also used to guide instruction and for progress monitoring. But in this segment, we're going to focus on the first point, writing goals that clearly identify the learning outcomes. The book Principles to Actions, which first introduced the 8 effective math teaching practices, has this to say about establishing mathematics goals. Effective teaching of mathematics establishes clear goals for the mathematics students are learning, situates the goals within learning progressions, and uses the goals to guide instructional decisions. Notice here there are 3 components. First, goals should clearly identify the math students are learning. Goals should be clear about the type of learning and the depth of that learning. Second, goals should be situated within learning progressions. That means goals should work together, like stepping stones to build our students' understanding toward all of the learning identified in the standard. And goals should also be used to guide instructional decisions. Everything we say and everything we do should be gauged against the goal. So let's break this down into something we can work with. Learning goals are the most effective at clearly defining what our students should know, the conceptual side, and be able to do, the procedural and application side. That is, our goals should clearly state the mathematical ideas, the concepts, the connections, and the relationships that we want our students to understand. And goals should also identify any procedural understandings we want our students to know. But keep in mind, if our goal is for students to gain a conceptual understanding, then that goal should not restrict students to a single procedure. We also need to make sure that our goal supports the learning in the standard. So our goals need to be standards-based. That is, we write our goals to address and support the learning identified by the standard. And going along with that is understanding where the learning of this lesson fits in the learning progression. Also important is when we're writing learning goals, we want to use action verbs. Things like students will describe, students will illustrate, students will generalize, students will compose. So here's a list of action verbs that's helpful when you're writing your learning goals. I've also included a PDF copy of this that's available on the slide after this video. Also important is how will students demonstrate the learning that's identified in the goal. The action verbs that you use to write the goal determine how students will demonstrate that learning. So when writing learning goals, keep the following questions in mind. What should students know and be able to do? How does this fit in the learning progression? What aspects of the standard is this developing? And how will students demonstrate the learning? The goals we sometimes see in textbooks are performance goals. And even though procedural practice is important, the book may not address the conceptual aspects of the learning or the standards. In those cases, it's important for us to look at how to rewrite a performance goal as a learning goal. So this performance goal states that students will be able to transform linear functions using the parent function as a guide. This goal aligns to the standard FBF 2.3, which states students will identify the effect on the graph of replacing f of x by f of x plus k, kf of x, and f of x plus k for specific values of k, both positive and negative. Students are to find the value of k given the graphs, and experiment with cases and illustrate an explanation of the effects on the graph using technology. The purpose of this standard is to develop students' understanding of those relationships between the parent functions and the transform functions. That is, we want students to grasp the relationship between the function equation and how K affects the graph of the parent. Does this performance goal support the depth of the learning that's identified in the standard? Not really. I mean, we do want our students to be able to do what's identified in the performance goal, but it really doesn't take the learning far enough. It needs to be clearer about exactly what we want our students to understand. So here's what the learning goals might be for transformation of functions. First, students will understand the parent linear function and the characteristics of its graph. Second, students will create graphs of linear functions that illustrate the different effects created by replacing the parent linear function f of x with f of x plus k, k f of x, and f of x plus k. Students will explain their solution. First of all, the learning goal better addresses the learning of our standard. But the learning goal also supports our students gaining a conceptual understanding of the relationship between what K is doing to the function and the specific change that's occurring in the graph of the function. And the lesson for this learning goal would develop this understanding through exploration, giving students different cases to explore, maybe using technology, graphing calculators, Desmos, GeoGebra, but they could even do this using pencil paper or graphing paper. And during those explorations, students can practice their fluency in transforming linear functions. The learning goals set students up with an understanding of linear transformations that can be applied later in contextual situations and is also the baseline for extending that understanding to transformations of other functions. Requiring students to explain their solution further supports what they're understanding, and it also gives us teachers a glimpse into what they really do know. I'm going to give you a performance goal, the standard it's related to, and I want you to try to write it as a learning goal.